Right, welcome everyone. So it's great to be back with another video. First of all, I want to say sorry for the delay since my last upload. Things have been a bit hectic, but at least here we are for today. So now let's dive into today's topic. Last time we worked on saving a customer to the database, and many of you seem to enjoy that tutorial. So today we are going to complete the puzzle by looking at how to update and delete the customer. And don't worry, I'll also walk you through the architecture of the project so you can get a clear picture of how everything fits together. Alright, so as you can see, this is our project, guys. So far we have done this save customer part. We were able to save a record to our database, and in the left side you can see several packages are here. uh, this is called layered architecture. Later I will explain what is layered architecture and how it will be an advantage for our developments. So let me run this application again. Okay, it's running, no any issues. After a successful run, you can come to the postman and provide some sample data. 305, this time I send Peter, and Peter is from Australia, the same, and his salary will be the same. Alright, let's click on the send button. Alright, we got this Peter saved message. It's a good sign for us. So let's look at the database, refresh it. Alright, as you can see, Peter has saved successfully. Right. Before we dive into the code, let me give you a quick overview of how this project is organized. We are using something called layered architecture, which is essentially about dividing the application into different layers. But why? To keep the code clean, modular, and easier to maintain. So let me explain why this is so powerful. Think of it like building a house. You wouldn't let your plumbing directly affect your electrical wiring, right? Similarly, in a layered architecture, each layer has its own responsibilities and works independently. The beauty here is the layers of isolation concept. What this means is changes made in one layer don't usually affect the others. For example, if we decide to switch our database to a new technology, that change stays within the persistence layer. The presentation layer, where the user interface lives, doesn't even notice the change. In our project, we have divided it into the following layers. Presentation layer. This is where the user interacts within the application. Business layer. This is where all the application logic lives. It's the brain of the system. Persistence layer. This handles interactions with the database, saving, retrieving, and updating data. Database layer. This is the actual database storing the data. The key takeaway is each layer focuses on its own job, which makes our application more organized and resilient to change. Here is how it is set up. First, we have the presentation layer. This is where we handle incoming requests. In our project, this is managed by the API package, which contains the customer controller class. This is where all the API endpoints are defined. Simply, we can say it's the front door of our application. Next is the business layer. This is where all the magic happens. That is our business logic for this app. We have got the service package for this. It has the customer service interface and its implementation, customer service IMPA. Now you might be wondering, why bother with an interface and its implementation? Why not just write everything directly in one class? Yeah, good question. Using an interface brings flexibility and scalability to our application. It's like laying down a blueprint for what needs to be done while the implementation class fills in the details of how it's done. This approach has several advantages. First one, loose coupling. The rest of the application only depends on the interface, not the specific implementation. This makes it easier to swap out or update implementations without breaking other parts of the code. Testability. With an interface, we can easily mock the implementation during testing. This makes testing individual parts of our app way simpler. Scalability. If we ever need to add a new implementation for handling customers, let's say fetching data from an external API instead of the database, we can do that without affecting the rest of the app. These handle all the core operations like saving, updating, and deleting customers. Alright, then we have the persistence layer, which talks to the database. That's the repo package in our project, containing the customer repo interface. Thanks to Spring Data JPA, this interface does most of the heavy lifting for us. Finally, the database layer, where the actual data is stored. Our entity package has the customer class, which maps directly to the database table. Now that you know how the pieces fit together, now let's jump into the code and see this in action. Alright, let's talk about updating a customer. The idea here is pretty simple. The client sends the updated details along with the customer ID and we handle the rest. So alright, this is our update customer method. Currently it's returning just a normal string. We are going to implement that update customer method to update the customer record. To do that, before do that, I want to show you this reference variable to customer repo interface. This is our customer repo interface and it has extended by JPA repository. Because of this extension, we have that ability to, let me show you, without returning this string. As soon as I type repo, you will notice it gives us access to a whole bunch of built-in methods like find by ID, save, and more. So these are super handy because they save us from writing a boilerplate code for database operations. So from those methods, I use this find by ID method because we need to update a specific customer. So to that method, I'm going to pass DTO dot. You can see that methods are coming. Get ID, and after that I'm going to introduce it to local variable called temporary customer. Alright, now I have to check is this customer is present in the database, otherwise it will give us an error. Alright, let's check that. Alright, I write the if statement here, and if I check is this temp customer is present. So if that customer is present, I'm going to update its attributes called name, address, and salary. So I'm going to get this customer temp customer dot get, and I want to set his new name. And what is the new name? That is come from the request from dto.getName. Alright, I have to write down two more to update its address and salary. Set address and dto.get address. Likewise for salary, set salary dto.get salary. Alright, after those all operations, I want to save this temporary customer to the database. To do that, I write repo dot save this temp customer dot get. Alright, if it saves on the database successfully, I'm going to return. I can write it on here. Return dot the customer's new name. Alright, otherwise if this customer is not present in the database, I can return a string called customer not found. Alright, now let's go to the controller class. This is our presentation layer. Alright, inside this method, update customer method, without writing this string, I want to write customer service inside that we have a method called update customer. To that update customer, we passed this DTO object. Alright, everything is fine. This is fine and this is fine. I'm going to rerun this application. As soon as you make a change to the application, you should rerun this application again. Alright, I'm going to rerun it. It's running. No any issues. Let me see the database. Let's update this Peter to a new location. Alright, let's go to the postman. Yeah, Peter here. Let's update its location to Maldives. Alright, and also salary to 90,000. Let's sorry, this is really important, guys. This is just a post method. This post method is used to save a customer, not for update a customer. So to update a customer, we have to use the put method. So I have written this put method, put request here. So same thing, but it's the change difference is we use put method instead of post method. So right, let's update. Let me copy this and paste it here. That will be easy for me. All right, update, everything is okay. Let's click on the same. All right, I got his name. Let's see the database. All right, just refresh the database. All right, as you can see, the location has updated. Likewise, you can update other attributes as well. All right, let's dive into the delete customer operation. So this method takes an customer's ID as its input, and we should implement the delete operation for that specific customer. Right, let's write without this return statement. I'm going to write as same as the update operation, repo.find by ID, because first we have to find out that specific customer for that specific ID. All right, so find by ID, I'm going to pass this ID, and after that I'm going to introduce it to local variable called temp customer. All right, then again I have to check if this customer is present. All right, I write this statement to check temp customer is present. If this customer is present, I'm going to delete that record. All right, to delete that record, again I'm call repo.delete method, this time delete method, and I should pass down the ID of this. I should pass down the customer entity for this delete method. To do that, I'm going to pass this temp customer dot get. All right, why it's giving a warning for me? All right, it says me to do this. I don't know. Let's perform it this way. That looks so familiar for me. So after that, I'm going to return that ID plus delete. All right, otherwise I'm going to return customer not found. All right, everything is fine. We got the temp customer from this repo.find by ID method. We passed this ID to this method, and we got the temp customer, and we check that customer is present here. If this customer is present, we call delete method and pass down that temporary customer to that method. After that, we return that that specific ID is deleted, otherwise we return customer not found here. Alright, let's go to the controller class. I have to change here also. Without returning this string, I'm going to call customer service dot we have delete customer method and pass down this ID to that method. Alright, let's run the application again. Alright, it's running. Alright, no any errors. Let's go to the postman. It's not like before. We have to use various methods called delete to delete a custom. We can't use either post or put to perform delete operation. So I'm going to use this delete operation. So I use this params, and for ID I pass down the customer's specific ID to the method. Let's see the database. Database has C05. Let's delete this C05 record. Alright, let's go to here. I type here C05. Okay, let's click on the send button. Alright, I got the message saying C05 deleted. It's a bit of messy, don't hear it. Alright, let's go to the database. Alright, here. Let's refresh it. Alright, as you can see, the record is disappeared. So that's how delete operation works. Alright guys, so that is the end of this tutorial. So we have successfully covered how to update and delete customers. Along the way, we took a look at a complete overview of the layered architecture. So in the next video, I'm going to cover pagination, which is a super handy feature to handle large data sets, and we'll complete our CRUD operations as well. So make sure to subscribe, hit the notification bell, and stay tuned for the next session. As I say every time, until then, keep learning, keep building, and I'll see you in the next video. So thank you everyone.